In this lesson, we are going to talk about how to change the quadratic form in vertex form to standard form. Before I start talking about this concept, just remember any quadratic can be written in three different forms. The first form is the standard form, which is y is equal to ax squared plus bx plus c. A, B, C are real numbers, positive or negative, and A cannot be equal to 0. The reason is that if A is 0, then you are going to end up with y equal bx plus c, which is a linear function. This is called the standard form. Standard form. Another form of a quadratic equation is the X-Intercept form or factored form, which is the form y is equal to a x minus r times x minus s. The rs are real numbers. These are the X-intercepts. Remember, X-intercept is where the graph crosses the x-axis. And this is the factored form. And the last form is the vertex form, which is y is equal to a times x minus h squared plus k. In this form, the vertex is the coordinate has h and k as the values. Again, h and k are real numbers, a also a real number, and a cannot be equal to 0. These three forms represent the same quadratic function. If you notice that in all of them, a is the same. It's the same value. Now, one thing remember is that you can always go from one form to another one. For instance, in this lesson, we're going to talk about how to change quadratic form in vertex 1 to standard form, meaning from this form to this form. To do that one, the only thing we do is that we expand the quadratic in vertex form as we did in the last lesson, and we get the standard form. In the standard form, the value c here is the coordinate of the y-intercept. Remember, the y-intercept is when x is equal to 0. So if in standard form I set x equal to 0, this term is going to be gone. This term is going to be gone because x is 0. We're going to end up with c, which is the y-intercept. As I mentioned before, the vertex form of a quadratic is in the form y equal a times x minus h squared plus k, where the coordinate of the vertex is h and k. One thing you have to remember, which is a lot of time is going to confuse students, is the vertex form is x minus h. So you have to consider that negative sign, and you will see why I'm saying this one. Now, the question is that if I have the standard form, how can I change it to vertex form? It's very simple. Either you can use this formula to find the value of h. Now, the formula says that h is minus b over 2a. You may say, what is b, what is a? Remember that the standard form was y is equal to ax squared plus bx plus c. So when you look at the standard form, your a value is the coefficient of x squared. So this one is the one which is multiplied by 2 and it goes in the denominator. And your b is the value of the coefficient of x. which goes in the numerator, and multiply by -1. If you divide -b by 2a, you get the h, which is the x coordinate of the vertex. To find the k coordinate of the vertex, you just put h back in the equation and then evaluate y. That's going to give you the coordinate of the vertex, which is h and k. This is one way. This is the shortcut. Very fast. You can find, the coordinate of the vertex. Another way of finding the coordinate of the vertex is to find the x-intercepts or the roots of quadratic equation in standard form, and then find the average of the two x-intercepts, x1 plus x2 over 2. Now you may say, how do I find the x-intercepts? It's very easy. You use the quadratic formula and you solve y is equal to ax squared plus bx plus c equal to 0. You get two x-intercepts, or two zeros. One is called x sub 1 and the other one is x sub 2. You average these two x1 and x2 together. This is going to give you your h value, and then you put h back in this equation again and you find the k value. This is going to be the coordinate of your vertex. Just to recall that for a quadratic equation in any form, standard, vertex, or X-intercept form, the value of a, if a is positive, meaning the leading coefficient is positive, the parabola opens upward. This means your vertex, which is your maximum or minimum, becomes minimum. If a is less than 0, the parabola opens downward. This means the vertex automatically becomes a maximum. And again, I repeat, if you want to change a quadratic equation from vertex form, which is y is equal to a times x minus h squared plus k, to a standard form, you have to expand this one. And we have already covered how you expand this one. You write this one as y is equal to a x minus h times x minus h plus k, and then you start multiplying every term, and you simplify, you get the standard form. And to change a quadratic from standard form to vertex form, you have to find the coordinate of the vertex, meaning that if I have a quadratic like y is equal to ax squared plus bx plus c, and I want to change it to a vertex form, which is this form, I have to find h and k. A is already the same as previous a, so I don't need to find a. To find h, I use that formula. H is minus b over 2a. And remember, b is this one and a is this one, so I can find h. When you find h, you put it back in this equation again because it's given, and you can find the value for k. When I know h and k, I can just write the vertex form very easily. In the first example, we have to find the standard form of each quadratic which is in vertex form. Let's first see why is this one in a vertex form. Remember, the vertex form is y is equal to a times x minus h squared plus k. If I compare this one with this equation here, you can see that a is equal to 1. Now, if you look at here, this is plus 6. The formula says minus h. So obviously, h has to be minus 6. because minus h is minus 6 gives us plus 6. And your k value, there is nothing here, so your k is 0. Now, to change the vertex form to standard form, I just use what I learned last lesson. So I'm going to write this one as x plus h times x plus 6. Again, I multiply the first term by every term in the second bracket, so x times x gives me x squared. X times 6 gives me 6x. Now the second term, 6 times x gives me 6x. 6 times 6 gives me 36. X squared, there is no like term, so it's x squared. 6x plus 6x is 12x. And then plus 36. So y equal x plus 6 squared, which is in vertex form, is the same as y equal x squared plus 12x plus 36 in standard form. And the coordinate of the vertex is h and k, which is negative 6 and 0. And also, because a is 1, which is positive, parabola opens upward. The next example, we have to change negative 2x minus 7 squared, which is the vertex form, to standard form. Again, before I do that one, I'm going to find a, h, and k here. A is obviously negative 2 because this is the value here. Remember, the vertex form in general is a times x minus h squared plus k. So a is negative 2, h, negative 7 is equal to negative h, so h is 7. And your k value is the constant here, which is 0. So your k is 0. So my vertex is hk, which is 7, 0. My a value is negative 2. Because it's negative, parabola opens downward. So this vertex, which is this point here, is going to be a maximum. Now, to find the standard form, I'm going to write this one as negative 2 x minus 7 times x minus 7. Now I'm going to multiply every term of the first bracket with every term on the second bracket. So my arrows goes x times x gives me x squared, so I get negative 2 x squared. X times negative 7 gives me negative 7x. Negative 7 times x gives me negative 7x. And negative 7 times negative 7 gives me 49. Negative times negative is positive. Now I get, there is no like term to x squared, so it's x squared. Negative 7 and negative 7 are like terms, so I get negative 14x and then plus 49. Now I multiply negative 2 by every term inside. I get negative 2x squared. Negative 2 times negative 14 gives me plus 28x. And negative 2 times negative 2 times 49 gives me negative 98. So my standard form is negative 2x squared plus 28x minus 98. And my y-intercept is the constant in standard form, which is negative 98. So my y-intercept is 0 and negative 98. The next example is the vertex form 3 times x minus 5 squared minus 8, and we have to find again the standard form. Before I do that, again, remember the vertex form is y is a times x minus h squared plus k. Comparing this with this equation, I get a is equal to 3. Now negative h is equal to negative 5. They are the same, so this means h is 5. And k is negative 8, this constant. So this means my vertex is at hk, which is 5, negative 8. Now my a value is positive 3. This means parabola opens upward. So the vertex, which is this point, obviously it's a minimum. Now let's change this into standard form. So y is equal to 3x minus 5 squared minus 8. Again, this is the same as x minus 5 times x minus 5 minus 8. I multiply every term of the first bracket with every term on the second one. So x times x and x times negative 5. So I get 3. X times x is x squared. X times negative 5 gives me negative 5x. Now the second term. Negative 5 times x gives me negative 5x. Negative 5 times negative 5 gives me 25 minus 8. Now this is the same as x squared. There is no like term, so it's x squared. Negative 5x gives me negative 10x, and then plus 25 minus 8. Now I multiply 3 by every term inside the bracket. 3 times x squared is 3x squared. 3 times negative 10 gives me negative 30x. 3 times 25 gives me 75, and then minus 8 here. Now there is no like term to 3x squared, so it's 3x. Negative 30x stays negative 30x because there is no like term, but I am going to combine 75 and negative 8, and I'm going to get plus 67. So this means that the standard form is 3x squared minus 30x plus 67, and the y-intercept is the constant here, which is 67, which is 0 and 67. Now we are going to talk about an application here. The problem says that the projectile can be modeled by the relationship y is equal to negative 4.9 t squared plus vt plus h. T is the time, obviously has to be greater than or equal to 0. Y is the projectile's height in meters, h is the projectile's initial height, and v is the initial velocity in meters per second. We are supposed to find the initial velocity, meaning v, and also we have to find the initial height. The thing that we know is that the maximum height is 50 meters, and it reaches that height at 3 seconds. As soon as you see the keyword maximum and minimum in a quadratic problem like this, we know that these points represent the vertex here because it's a maximum. So this means that our vertex is going to have the coordinate v is 3 and 50. Now, one thing I have to say is that this problem is a little bit confusing because this parameter here is called h. And this is not the x-coordinate of the vertex here, this h. So keeping that in mind, I know that the vertex has the coordinate of 3 and 50. But remember that in a quadratic equation, the x-coordinate of the vertex, which is 3 here, is equal to minus b over 2a. This is what we covered before. Now our B coordinate is V here, which we don't know what exactly is B. So I can write negative V over 2A. So it's going to be 2 times negative 4.9 here. Now, negative over negative gives me positive, so this is V over 2 times 4.9 gives me 9.8. Now, 3 here is the same as 3 over 1, so I can cross multiply. This gives us V times 1 is the same as 3 times 9.8. V times 1, 3 times 9.8. Now V times 1 is the same as V, so I get V is 3 times 9.8 gives me 29.4. So this means that the coefficient of t in above quadratic formula in standard form is 29.4. And by the definition, v represents the initial velocity. So this means the initial velocity of the projectile is 29.4 meters per second. Now to find h, I'm going to use the fact that the y-coordinate of the vertex is 50. So this means that if I substitute 29.4 in this equation and solve for h, I can find the initial height of the projectile. So now to find the value for h, remember the vertex is 350. So this means that if I substitute 3 back in the equation, I have to get y equal 50. But knowing the fact that v is 29.4, I can solve for h. How we do it is very simple. We know that the y value of the vertex is 50, so I can write 50 is equal to negative 4.9 t squared. I just substitute 3, so times 3 squared, plus vt, but we found that v is 29.4. So I get plus 29.4 times t. T is the coordinate of the vertex, the x coordinate, which is t, which is 3, plus h. Now I have one equation in one unknown, which is h, and I can solve it. So I can write 50 is equal to negative 4.9 times 3 squared. 3 squared is 9. 9 times negative 4.9 gives me negative 44.1, plus 3 times 29.4 gives me 88.2, plus h. Now, if you solve this one by moving this to the left and this to the left, I get h is 50 plus 44.1 minus 88.2. If we solve this one, we get h is equal to 5.9 meters. So the initial height of the projectile is 5.9 meters, and the initial velocity of the projectile is 29.4 meters.